Hey everyone, I'm back. We're going to now talk about basically start to finish how to graph a polynomial function. So this is the function that we have. We're going to follow a series of steps to go through this, and then that'll help you to do that one problem or that series of problems on your assignment. I believe it's problems 6, 7, 8, and 9. This is kind of wrapping that all up into a single problem. Okay, so the first thing that we're going to do is figure out what our possible rational roots are. This is something that we've already done before, so this should be familiar to you. Remember, our possible rational roots are when we take all of the factors of our constant term divided by all of the factors of our leading coefficient. So all of our factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and all of the factors of our leading coefficient are plus or minus 1. So that leaves us with plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8 as our possibilities of rational roots or zeros. Now, we're just going to have to go through doing some synthetic division to figure out which one of these works. So I'm going to start with 1. My coefficients are 1, 3, negative 6, and negative 8. So let's see, 1 times 1 is 1. Add those together, 3 and 1 is 4. 1 times 4 is 4. Add those together, I get negative 2. 1 times negative 2 is negative 2. Add those, I get negative 10. Remember, this last number is your remainder. I don't want a remainder, so that doesn't work. Let me go ahead and try negative 1. So I have 1, 3, negative 6, and negative 8. Bring down that first number. Negative 1 times 1 is negative 1. Add those, I get 2. Negative 1 times 2 is negative 2. Add those together, I get negative 8. Negative 1 times negative 8 is positive 8, and when I add those, I get 0. Bingo, I found a root. Okay, so I know that one of my roots or one of my zeros is negative 1. So I have x is equal to negative 1. I know that's one of them. Now, take those coefficients and write your new polynomial. I started with x to the third, so my new polynomial will start with x to the second. So I have 1x squared plus 2x minus 8 is equal to 0. This I can factor. Two numbers that add to 2 and multiply to negative 8, x plus 4 and x minus 2. So set each of your factors equal to 0 and solve. I end up with x equals a negative 4, and I have x is equal to positive 2. It's a third degree equation, and I have 3 roots. Okay? So I'm just going to go on to the next page here just because I have a little bit more room. So this is the same exact problem. Let's write out our roots. We had x equals negative 1. We had x, excuse me, was equal to 2. And we had x was equal to negative 4. So those are our 3 roots. That's where our graph is going to cross the x-axis. So I know I'm going to have a point right here. I know I'm going to have a point at 2. And I know I'm going to have a point at negative 4. We did talk about multiplicity, and remember that we said if the root shows up an odd number of times, we will just at that point will just cross the x-axis. So each of these roots only shows up once, which means they have a multiplicity of 1, which means that each of these zeros, we're just going to cross through the x-axis. That's going to come in handy when we go ahead to graph it. Okay, so let's plot a couple other points. Here are the points I'm going to look for. I'm going to look for a y-intercept, where I cross the y-axis. Where you cross the y-axis is where x is 0. So I want to find f of 0. All that means is in that original function, plug 0 in for x. So 0 cubed plus 3 times 0 squared minus 6 times 0 minus 8. We get f of 0 is equal to negative 8. So 0, negative 8 is also a point on my graph. I'm going to plot that point as well. So far, the only things I've done is I found my zeros and I found a y-intercept. So those are going to be the first couple of things that you want to go ahead and do. Okay? So if you look at your assignment, identify the possible rational roots. That was this step up here. Identifying the zeros, we did that down here, so that takes care of 6 and 7. Problem number 8 says describe the end behavior. So let's talk about end behavior. I know that the end of my graph, first of all, I know it's an odd degree. If you go back to what we talked about in the last video, odd degree and positive leading coefficient. So odd degree and positive leading coefficient tells me my end behavior is going to be like this. Okay, like this right here. So I know that my end behavior is going to be this. My end behavior is going to do this. Okay. So far I have roots, I have a y-intercept, I know my end behavior. But what else do I need? Well, what's happening between my zeros here? Okay, what's happening between my zeros? So what's happening, if I look here, what's happening at negative 3, for example? What's happening at negative 3? Or what's happening at negative 2? What's happening between these points here? That's what I'm trying to figure out. And so, because here's the deal, folks, I can sketch a graph, but I might sketch it wrong in between. Maybe this graph goes way up like this in between, or maybe it just does this. Okay, this is my last, right? I'm crossing the x-axis in these 3 spots. My end behavior is telling me what's happening on the ends. So on the end here, on the right, my graph is going up. Going up. Somehow it's going up. And over here, somehow it's going down. But so it's going down, but then what's happening in here? Do I go way up like this and then come way back down? Or do I just go boop like this and then come down? You see what I'm saying? It's figuring out what's happening between those zeros. So let's see if we can plot a couple more points. Let's look at f of negative 3 and see what's happening there. All I'm going to do is plug negative 3 in for x. Okay, all I did was in my original function, I just substituted in negative 3 for x. I put it in parentheses, and then you can just put this entire statement in your graphing calculator all in one shot and have the calculator do it for you. It comes out to be 10. So when x is negative 3, I'm way up here at 10. I could also do at 1, figure out kind of what's happening here at 1. So let's try f of 1. I'm going to do that same thing. 1 to the third plus 3 times 1 squared minus 6 times 1 minus 8. Again, put it in your graphing calculator as one long statement and then just hit enter, and that will give you negative 10. So when f is 1, I'm down here at negative 10. All of these points here are basically helping me kind of get an idea of what this graph looks like. So if I were to go ahead and connect those points, now I know my end behavior tells me I have to be down here. It tells me my graph is going to go up. I'm going to come way up here. I'm going to come back down like this. Whoops. Back down here through that point. Come back down like this. And then I'm going to come back up through that point. And that is a sketch, obviously not the best sketch, but that's a sketch of what your graph, I don't sketch very well on this little pad thing, but that's basically the shape of your graph and what it looks like. Notice I plotted just a couple of points between my zeros to get an idea of where my graph went, because I didn't know if it went up really high or if it was just going to be a little hump in here. So I needed to figure out what was going to happen there. That's why I plotted those extra points. And that's the idea behind what's going on there. Okay? Another interesting piece of information for you. I have two turning points, right? And my graph turns here and my graph turns here. Whatever the degree of your function is, you'll always have at most one less turning point than the degree. So this is a third degree polynomial, and I have two turning points. If I had a fifth degree polynomial, I'd have 4 turning points. If I had a 4th degree polynomial, I'd have 3 turning points. Okay, so that's the idea. All of those little tips and tricks kind of help you to graph or sketch a graph of that particular function. But you do have to go through these steps to do that. So on your assignment, you do have to go through all those steps to go ahead and sketch that graph. Okay. Problem number 10 on the assignment, you can actually put it into your calculator and go ahead and graph it, and then it asks you to find the minimum number of subscribers and the year in which it occurs, so you can get that from the graph. Give that one a try. We can always go over that one in class tomorrow, okay? But basically that's the idea behind sketching your graph. Again, just real quick, start with finding your zeros, look at your end behavior, find your y-intercept, and plot a couple of extra points, and that'll help you sketch the graph. I'll see you all in class tomorrow. Have a great day, everybody. Take care. Bye-bye.